Hi, I'm Mona and today I'll be leading you through the intriguing world of organic or carbon-based substances. First, we'll learn what organic compounds are and why carbon is such a unique element. Then we'll talk about hydrocarbons, their classification, isomerism and IUPAC nomenclature. Finally, we'll help you build a strategy to take on those all-important exam questions in Exam Decoded. As you saw, organic compounds are all around us. But what exactly is the meaning of organic? Simply put, organic substances are the compounds which carbon makes when it associates with different substances. But carbon oxides, carbonates and hydrogen carbonates are not organic. Did you know? Earlier, scientists believed that organic compounds were present only in living systems. But in 1828, German chemist Friedrich Wöhler disproved this by synthesizing an organic compound, urea, from an inorganic compound, ammonium cyanate, in the laboratory. Since carbon is a common factor in all organic compounds, you may wonder what makes carbon so special. To answer this, we need to understand its atomic structure and how it bonds with other atoms. Carbon atoms are tetravalent. That means that 4 valence electrons of one carbon atom can be shared with other atoms of carbon or other elements, forming a stable covalent bond. For example, in methane, one carbon atom bonds with 4 hydrogen atoms. Carbon has another unique property, catenation. Catenation means the ability of carbon to form bonds with itself. Because of this property, it is possible for carbon compounds to have long-chained molecules of unlimited size and complexity. This is why carbon forms more than 7 million compounds. Catenation also enables carbon to form differently shaped chains which can be long and straight, branched or ring-shaped. Carbon can also form multiple bonds. That is, it can form single, double and triple bonds. In ethene, which has a carbon-carbon double bond, 2 pairs of electrons are shared between the 2 carbon atoms. In ethyne, 3 pairs of electrons are shared between the 2 carbon atoms. And the final reason for carbon's uniqueness is the stability of the carbon-carbon covalent bonds. Unlike other tetravalent bonds like silicon-silicon, the carbon-carbon bond is very strong, making the resultant compounds very stable. Can you think why this happens? Well, the science is simple. It's because carbon is small, which means that its nucleus holds on to the shared pair of electrons strongly. Hydrocarbons are a special group of organic compounds. These are substances that contain only carbon and hydrogen. For example, methane or CH4 and ethene C2H4. These compounds are classified depending on the type of carbon chain they have, whether they are open chain compounds or cyclic or closed chain compounds. Open chain hydrocarbons are called aliphatic compounds. They can be further classified into saturated and unsaturated hydrocarbons. Hydrocarbons in which all carbon atoms have 4 single covalent bonds are called saturated hydrocarbons. They are also called alkanes. For example, methane CH4 and ethane C2H6. On the other hand, hydrocarbons in which at least one carbon has double or triple bonds are called unsaturated compounds. The second type of hydrocarbons, that is, the cyclic compounds, are further classified into 2 types. They are called alicyclic compounds if they have no benzene ring in their structure. They are called aromatic compounds if they do have a benzene ring in their structure. What does this mean? Let me make this clearer. Benzene is a hydrocarbon that has a ring-like hexagonal structure. That is, 6 carbon atoms bond with each other, with the carbon at each vertex bonded with one hydrogen. In order to complete its tetravalency, carbon atoms form double bonds with the adjoining carbon atoms. The alternate double bonds are represented by a ring. When the hydrogen bonded to carbon is substituted with halogens or radicals such as hydroxyl groups, the derivatives are known as aromatic compounds. Now, let's study unsaturated hydrocarbons. Every type of hydrocarbon is characterized by specific structure and properties. First, we have the alkenes, which have double carbon-carbon bonds and are also called olefins because they form oily liquids on reaction with chlorine gas. This group of compounds has the general formula CnH2n, where N is the number of carbon atoms in the alkene molecule. Compounds with a triple carbon-carbon bond are known as alkynes. Now, since there is a triple carbon-carbon bond, carbon needs less number of hydrogen atoms to fulfill its tetravalency. Simply put, that means the general formula for alkynes is CnH2n minus 2. The first member in this series is ethyne with the formula C2H2 into 2 minus 2 or C2H2. You need to know that ethyne is also commonly called acetylene and alkynes are also known as acetylenes. Either of the names may be used in exam questions, so be careful to memorize them. You may have realized that it's not easy to remember the names of organic compounds. So, in the next segment, I'll explain how to name them in a systematic manner. Meanwhile, why don't you try this question? Name the hydrocarbons which are also known as paraffin. Need a spot of revision to answer this? Then log on to topperlearning.com and join me after the break to check if you are right. Welcome back to Introduction to Hydrocarbons with me, Mona. In the previous segment, I had asked you, name the hydrocarbons which are also known as paraffin. Well, paraffin literally means inert in Latin. So, alkanes are called paraffins as they are chemically inert. Well, let's talk about how hydrocarbons are named. Earlier, compounds were named according to their source. So, what we know as methane or CH4 was referred to as marsh gas as it was found mostly in swamps. Similarly, acetic acid was called so since it was obtained from vinegar, acetum being the Latin word for it. These names are still widely used and are called common or trivial names. But over time, this system of naming could not be maintained as more and more hydrocarbons were discovered and even synthesized in labs. And so, it fell upon the International Union of Pure and Applied Chemistry or IUPAC to come up with a better method. So, listen carefully to the rules that govern IUPAC's system of nomenclature. The name of a hydrocarbon consists of two parts, the word root and the suffix. The word root depends on the number of carbon atoms in the longest carbon chain. Take a look at this list of word roots. representing the number of carbon atoms. The suffix follows the word root and represents the type of carbon-carbon bond. The suffix "ane" is added for single bonds, "ene" is added for double bonds, and "ine" for triple bonds. Not so complicated, is it? Let's see what this caller wants to know.
Hi, what would you name a compound with molecular formula C4H10?
Okay, first we should write down the structure of C4H10. As you can see, this carbon chain has 4 carbon atoms. So, according to IUPAC convention, the word root will be bute. And since there are only single carbon-carbon bonds, the suffix will be "ane". So, this compound is called butane. Ready for another? Take a look at this structure and name this compound. Here, the word root will be eth since there are 2 carbon atoms. But because the compound has a double carbon-carbon bond, the suffix will be "ene". So, the IUPAC name will be ethene. The science, as always, is simple. As chemistry students, I'm sure you know that just giving compounds names isn't enough. One must also know their molecular formula. And when it comes to hydrocarbons, one must also know their structural formula and condensed formula. Molecular formula shows the actual number of each type of atoms present in the compound. For example, propane or C3H8 has 3 carbon atoms and 8 hydrogen atoms. In structural formulae, we see the actual arrangement of atoms in a molecule. So, the structural formula for propane shows that 3 carbon atoms are linked in a straight chain and hydrogen atoms are added onto the carbon. Finally, the condensed formula of a hydrocarbon is the shortened form of the structural formula. For propane, the condensed formula is CH3, CH2, CH3. It's important to study these 3 types of formulae in order to understand the next interesting property of hydrocarbons: isomerism. Isomerism is a property of compounds to have the same molecular formula but different structural formula. These compounds are called isomers. In other words, one molecular formula can represent more than one compound. How is this possible? Let's take the example of an alkane, butane, which shows isomerism. Since there are 4 carbon atoms, there are 2 types of carbon skeletons possible. One is a straight chain of 4 carbons and the other is a branched chain. Filling the remaining valencies with hydrogen, we get 2 isomers of butane: normal or N-butane, where carbon atoms are attached to a maximum of 2 more carbons, and isobutane, where carbon atoms are attached to a maximum of 3 carbon atoms. This kind of isomerism is called chain isomerism. Now, it's important to remember 2 points when talking about isomers. 1. Only alkanes with more than 3 carbon atoms can have isomers. And 2. The side chains cannot be present on the carbon atoms at the ends of the chain. Why not? It's common sense. Then the branches will be considered extensions of the straight chain. But what about alkanes that have more than 4 carbon atoms? In such compounds, more than one carbon can move from the parent chain to the side chains, and those isomers are called neoalkanes. An important thing to remember in isomers is that the side chains cannot be present on the terminal carbons, because if they are present on first or last carbon, then they are a part of parent chain and not branches. Have a look at this graphic to understand it better. They all are straight chain hexanes. Take a look at the example of pentane with 5 carbon atoms and 12 hydrogen atoms. The first isomer is called N-pentane as it has straight chain normal structure. The second isomer is isopentane as it has one branch. In the third structure, there are 2 branches, so it is called neopentane. Overall, there is no change in the number of atoms of each kind or in the molecular formula. How does isomerism occur in compounds with double bonds? Let's see what happens in the case of butene, which has 4 carbon atoms and 1 double bond in its structure. The possible structural isomers are but1-ene, that is butene with CC double bond in position 1. The second isomer is but2-ene, that is butene with carbon-carbon double bond in the position 2. Here, since the differences arise due to the position of the double bond, the isomers are called position isomers. For those of you who find isomerism a little confusing, I recommend that you check out more examples and sample problems on topperlearning.com. Remember, questions based on this topic are very popular with the examiners. What else can you expect in the exams? Why don't you join me after the break to find out? Welcome back. You've been unraveling the chains of hydrocarbons with me, Mona. And now it's time for a quick revision of what we have learned so far. Carbon is tetravalent and forms covalent compounds by sharing 4 valence electrons. The self-linking property of carbon atoms through covalent bonds is called catenation. Hydrocarbons are broadly classified as open chain compounds and cyclic or closed chain compounds. Hydrocarbons in which all carbon atoms have single covalent bonds are called saturated hydrocarbons. Saturated hydrocarbons are called alkanes. Hydrocarbons in which at least one carbon has double or triple bonds are called unsaturated compounds. Compounds having carbon-carbon double bonds are known as alkenes. Compounds having carbon-carbon triple bonds are known as alkynes. Compounds that have the same molecular formula but different structural formula are called isomers, and the property is called isomerism. So, how can you link this chain of facts with a string of exam successes? Let's find out in Exam Decoded. Welcome to Exam Decoded. But before I give you those exam tips, let's play a round of rapid fire, which is a fun way to figure out how prepared you are for the exams. The rapid fire rules are really easy. I'll ask you 5 questions, each of which you must answer in 5 seconds. You'll score 1 mark for each correct answer, and I'll help you interpret your total with our special topper scorecard. So, let's begin. Your first question is, Marsh gas is another name for A. CH4, B. C2H4, C. C2H6, D. C2H2. The right answer is CH4 or methane. Name an alkyne with 3 carbons. Is it A. Propane, B. Propene, C. Propyne, D. Propyl? Since the chain contains 3 carbon atoms, the right answer is C. Propyne. Your third question is, N-butane and isobutane are A. Position isomers, B. Chain isomers, C. Functional isomers, D. Allotropes. The correct answer is B. Chain isomers. Question 4 is, how many bonds does ethane with molecular formula C2H6 have? A. 6, B. 7, C. 8, D. 9. The answer is B. 7. There is 1 carbon-carbon bond and 6 carbon and hydrogen bonds. Just one more question to go. Which of the following is unsaturated? A. Ethane, B. Butane, C. Propyne, D. Hexane. The right option is C. Since propyne contains a triple bond, it is unsaturated. And now for the score. Compare your total to our scorecard and see where you fit. If you've scored full marks, then you are a high flyer and can rest assured that your preparation is going well. If you've scored 4 or 3, then you are an achiever with just a bit more revision of sample questions required. If you've scored less than 3, then you need help with the basic concepts of the topic. You can get this help on topperlearning.com, where we have specially designed a list of tips and revision points. Now that we know where you stand, let's take a closer look at the exam trends. Today's topic is a part of the unit Carbon and its Compounds, which makes up 18 marks of the total 60. This makes it a critical unit to focus on. The topic, Introduction to Hydrocarbons, accounts for 6 to 8 marks. In terms of the types of questions expected, you are likely to get knowledge and conceptual ability questions. These will test your conceptual ability, that is, how well you use the concepts learnt to solve complex problems. You may also be tested on your knowledge ability, so brush up all those facts, definitions and formulae. Here is a really simple 3-mark question that calls upon your knowledge ability. Write the structural isomers of pentane. We know that the molecular formula of pentane is C5H12. As we studied earlier, there are 3 possible isomers. Each isomer's correct structural representation will fetch you 1 mark. The first is the straight-chained normal or N-pentane. The second isomer is isopentane, as it has 1 branch. In the third structure, there are 2 branches, so it is called neopentane. This question shows you how important it is to revise and practice structural diagrams. What else do you need to pay special attention to? Let's ask today's expert.
The word isomerism, if you split it, iso means same, mer means unit, ism means a phenomena. That is a kind of a same unit phenomena. Actually, when you see the organic compounds, I said that the carbon can be linked in different forms. So when you have the different forms, we have what is called as different structures. That structures can be written in a 2-dimensional way in your notebook, or you can even make models in space. Whatever it is, one particular compound can be represented in 2 or more different ways. That means they are structurally different, and the total number of the atoms which are present are same. Such compounds are called as isomers. That is, isomerism is a phenomena where 2 compounds have same molecular formula but different structural formula.
We've reached the last link in today's session on hydrocarbons. Remember, this topic affects almost every part of our existence, including one of the most pertinent issues confronting man today, fossil fuels. Let me leave you with this brain teaser. Coal, crude oil and natural gas together constitute fossil fuels. But which one of the three is odd one out? Dig deep for the answers, keep studying, and remember to log on to topperlearning.com if you require any assistance in revision. Until next time, goodbye.